Section 4.3, applications of systems of linear equations. Of course, applications means word problems. I don't really care how you get these worked. This section gives you an alternate way of setting up word problems. You're going to use two variables. It's usually easier to set up a problem using two variables than it is to set it up with one, but it's usually more difficult to solve because you have to solve a system instead of a single equation. It's a trade-off. I say whatever way you see to set it up first, that's the way you should go with, okay? If you choose two variables, you have to have two equations. If you set it up with one variable, you only need one, okay? So we're just going to talk about various types of problems again, all right? If we have a geometry problem, you want to draw pictures, always, okay? Fred and George found that the width of their Quidditch pitch was 44 meters less than the length. If the perimeter was 288 meters, what was the length and width of the pitch? Okay. So we're given length and width. We have, although it doesn't tell us, a rectangular field. And we have, this would be our width, this is our length. Okay, the perimeter of a rectangle is the distance all the way around. And so what we know about rectangles is that this is W, okay, and this is also L. So the formula for the perimeter of a rectangle is L plus L, which is 2L, plus W, which is 2W. 2 times the length plus 2 times the width. Okay, so if I use the variables W and L, my first equation is 2L plus 2W is equal to 288, because that's my perimeter. Okay, so I've used this. Let's look at the other numbers we haven't used. The width was, so this is W is equals 44 meters less than, okay, this is a translation problem in here. That's some sort of subtraction. And if you remember, subtractions we have to really think about. Less than the length. Okay, so the width is, okay, it's either 44 minus L or it's L minus 44. Okay, I make $44 less than you. To find out how much I make, I would take what you make and subtract 44, right? So I take the length and subtract 44. Length minus 44. Okay, so this is the system I need to solve. Now, we're not told to solve using any particular method. We could graph these if we wanted to. It's going to be awfully hard to do, but we could. We can use substitution or we can use elimination. Now, you probably have a favorite method. That's perfectly okay, completely understood. But sometimes the problem is just set up for you to better use one than the other, okay? This one is already solved for W, so I think substitution is probably easier. I'm going to take all of this and plug it in to W right here. So I would need to solve 2L plus 2 times, instead of W, I write L minus 44. And this has to equal 288. Okay. One thing I want to point out is if I had set this up with one variable alone, I would have had W on this side instead of L here. I would have put, actually no, I said that backwards. I would have L here, and then I would have L minus 44 here. And then when I go to find the perimeter, I would end up with exactly this equation. So basically, when you set it up with one variable, you're actually doing the substitution method without writing down the substitution method. That's why this ends up being more difficult, okay? Anyway, that's an aside. Let's distribute this 2. And I get 2L plus 2L minus 88 is equal to 288. Okay. Combining like terms, that gives me 4L minus 88 is equal to 288. Okay. So let's add 88 to both sides. And we get 4L is equal to, what is 288 plus 88? You get 376. Now let's divide both sides by a 4. And we get the length is 94. We are asked to find both the length and the width. So I need to take this and plug it back in here somewhere to find width. It looks easiest to do it in here. My width would be 94 minus 44. So my width is 50. Make sure I answer the question. We're asked to find length and width, and my measurements are in meters. So it is 50 meters by 94 meters. And that would be my answer. Okay, so let's try a mixture problem. For me, the easiest way to do a mixture problem is to draw and label beakers. Okay, the final percentage, which is the concentration, must be somewhere between the two concentrations that are mixed together, just as something to keep in mind. And whichever starting concentration is numerically closer to the final concentration is the one we'll need more of. I'll talk through this once we get this picture drawn. Okay. How many liters each of 15% acid and 33% acid should be mixed to get 120 liters of 21% acid? Okay. So I'm going to be mixing 15% acid. Okay. And I'm going to be mixing it with some 33% acid. And I want to end up with 120 liters of 21% acid. Okay. Now, what we set up here is the final concentration must be somewhere between the two concentrations that are mixed together. 21 does fall between 15 and 33. Okay. Now, what this says is whichever concentration you're numerically closer to is the one that we're going to need more of. So let's talk about which one of these 21 is closer to. 21 is 6 away from this one, right? So I'm just going to make a little 6 mark up here. And 21 is 12 away from 33, correct? Okay, so this tells me 21 is closer to this value. So I need more of this one than I'm going to need of this one. So this one is going to be more, and this one's going to be less. And that's what we can tell without really doing much math. Okay, now I need to know how much of each of these to mix together. Let's say I'm going to need X of this and Y of this. Okay. What we can do first is we can set up our general mixture problem equation, where we take percent times amount plus percent times amount equals percent times amount. Okay, so this will be 0.15x plus 0.33y. And over here on Scratch, I'm going to do 0.21 times 120 to get 0.21 times 120 is 25.2. So I'm going to use 25.2 right here. Okay, so that's one equation written. The second equation is exactly how much fluid we're mixing together. If I take X liters and I pour in Y liters, I get 120 liters. So that means X plus Y has to equal 120. This is the system I need to solve. Now I could solve one of these for X or Y, which would probably be this equation, and then solve it using substitution. I actually like elimination better here because my X and my Y are on the same side. Don't let the decimals mess you up. Just pick one of these to get rid of. Since these are both ones in front, it's not going to be that difficult. Just because this is a smaller number and no other good reason, let's get rid of X. I'm going to multiply everything by 0.15. So this system will become, recopy the first one, Double check that you haven't made a mistake. Okay, now multiply negative 0.15 through here. Negative 0.15 times 120 is negative 18. Add these together. This will cancel out. Negative 0.33y minus 0.15y is 0.18y. 25.2 minus 18 gives me 7.2. Now divide both sides by 0.18. And we end up with y must equal 40. Okay, now I found one. I'm asked to find the concentration of both of these. So I'm going to take this and plug it in either here or here. And I'm plugging in here because it's much easier. That gives me x plus my y is 40 is equal to 120. Subtract 40 from both sides, and we get x is equal to 80. So we have found out, we're asked to find how much of each. We found x and y. So I'm going to need 80 liters of the 15% solution, which is the one I need the most of. And I need 40 liters of the 33% solution, which is the one I thought I needed less of. So this checks out. Okay, so those are your two answers.